Very good evening, all my dear students. How is everyone? I hope you are doing great. Kids, so really very awesome session. It's alkynes from NCERT. So today definitely this most awesome, better to say fantastic, really fantastic chapter we are going to cover. Just wait for a second. First of all, just do let me know that am I perfectly audible and visible to all of you. Everyone in the chat section, very good evening. Manik, Shishma, I can see GD and each and everyone. Manik Pal, hi, I can see you. But first of all, everyone, do let me know that everyone can hear me, see me. So we are going to start with alkynes, and definitely we will go line by line according to NCERT. And today we have to dissolve this alkyne chapter in our blood. Wow, that's really awesome that Akanksha Singh is there, Sushma is there, each and everyone is there. And kids, really, I was eagerly waiting for this session because it holds a hell lot of weightage. But I cannot see the chat section according to what I was telling you. I can't see the fire in the chat section. Darshini Selvan is there. Priyanka, hello. Shubhashri is there. Santhur is there. Hey, yes, Santhur. Now you know the drill. That if I'm perfectly audible and visible, just I want to see some fire in the chat section. Hey, how is everyone? Do let me know that how are you doing? Perfectly good. Kids, let me tell you, whenever we are going to deal with this chapter, try to dissolve all the reactions in your blood so that the reaction should stick to your photographic memory, because this is going to be most important chapter. So everyone ready? Let me tell you, this alkynes, each and everything of alkynes. But if you're new to this channel, let me tell you that myself, Harin Singh Parihar, students, they are saying that your HSP Baba magical chemistry guru. I did my MTech in 2004 and I was MSc topper, gold medalist. My kids, those who are regular students, really they know each and everything, but for new students. So after doing MTech, and you can say MSc, after passing MSc, I qualified GRF, GATE, and then I took admission in MTech in 2004. I did that. I have been teaching for last 23 plus years and produced number of ranks. So kids, this is a, you can say, brief introduction about your HSP Baba. Now let's start. I can see Nana, I can see Ramesh, I can see Priya is there, Rani is there, everyone is there. So if you're new to this channel, please, kids, everyone, those who are new, subscribe to this lovely channel. And for all regular students, hit the like buttons. I can see students are more and likes are less. This is yours, only yours, Unacademy NEET English channel. So for your channel, hit the like button, smash it, smash the like buttons, everyone, so that your HSP Baba is going to start this new chapter, the awesome chapter, in one shot. I'm going to cover it up. So let's start the alkynes. So alkynes. Let me tell you each and everything about alkynes. Now, if there is an alkyne, let us suppose if I say there is CH triple bond CH, this is your ethyne. Everyone knows this is being ethyne, but in examination, the student who has got 5th rank, all India 5th rank, he got confused. See, yeah, you will get the PDF. Don't worry, you will get the PDF. Once in the examination its name was given as acetylene. And how he got confused? See why he got confused. Ene. You know, if somewhere ene is written, what do you mean by ene? You will say, oh my god, ene means alkene. So he got confused with ene. Kids, this is the journal name. Let me tell you, this is the journal name. Journal name is also known as trivial name, or we can say common name. And these names, they do not have any rules. They don't have any rules. So don't get confused with this name. Why this ene is there and why not it's alkene? Actually, its IUPAC name is ethyne. This is having rule that for triple bond we will say ine. So these are some concepts where people, they definitely are going to get failed. Now, next thing, let me tell you about this, that if you are going to deal with this compound, if I say that alkynes are sp hybridized, why they are being sp hybridized, you can see this is one pi bond, this is one pi bond, and this is being sigma bond and sigma bond. Only two sigma bonds. So what's the steric number? If I say this carbon's steric number is two sigma bonds plus zero lone pair. So 2 means sp hybridized, sp. Now, if I ask you kids, what is the electronegativity of this carbon? Is the electronegativity fixed? No. Every element's electronegativity depends on its hybridization. So this carbon is even more electronegative than nitrogen. Its electronegativity is 3.25. See, nitrogen's electronegativity is how much? Just 3. Remember that nitrogen's electronegativity is only 3, but sp hybridized carbon's electronegativity is 3.25. How much? 3.25. How much? 3.25. Let me write down once again. What is written over here? 3.25. So whenever you are having carbon which is being sp hybridized, its electronegativity is 3.25. That means this hydrogen can participate in hydrogen bonding. Do remember, everyone. Srinath, okay, very good, Srinath. Let me tell you, this hydrogen can participate in hydrogen bonding. This hydrogen can participate in hydrogen bonding. Now question arises, why? Because it is this carbon is highly electronegative, so this is having too much positive charge. That means this hydrogen can participate in hydrogen bonding. And one more thing, let me tell you one more thing. This hydrogen is being acidic hydrogen. So if the hybridization is getting changed, then the electronegativity is getting changed and the environment is getting changed. Do remember two things. That's this hydrogen is being acidic hydrogen and it can participate in hydrogen bonding. Now let me tell you about the hybridization, how the hybridization is taking place, because this is really very, very important. This is one carbon. This is another one carbon. And how the hybridization has taken place, see to it. sp, what does sp means? sp means 50% s character. 50% s character. That means this is sp, and this carbons, this is sp and this is sp. So these two are sp, and it is going to form a bond with hydrogen. This is hydrogen's one electron, This is hydrogen's 1 electron, and this carbon's 1 electron is like this, and this carbon's 1 electron is like this, and this carbon's 1 electron is like this, and it is over here. You can see very clearly. Now this much is clear. This is linear shape, linear. It's like this, linear shape. Are you getting my point? Everyone try to understand. This is being linear in shapes. Let us suppose I'm carbon and these hydrogens are going. These are two carbons. My shoulders are two carbons. One hydrogen is coming towards your side. One hydrogen is going toward that side. This is linear shape, linear shape. Now, try to understand where is p orbital. P is going like this, 1p. It's going like this. And this carbon is also pure p, unhybridized orbital. Unhybridized. This is unhybridized, or you can say this is forming a bond like this. A bond like this. This is the bonding which is taking place in these p orbitals. Let us suppose this is x-axis. This is being x-axis, and let us suppose this is being y-axis. Y-axis. So this is not participating in hybridization. Now this carbon is like this, and one p orbital is going above the plane and below the plane, and another p orbital, see, another p orbital is going on the z-axis. Z-axis. Just try to understand it, kids. Z-axis. Are you able to see that this is forming bond over here? So this is being x-axis, this is being y-axis, and I would like to say this is being z-axis. Z-axis. Is it clear? This is unhybridized, this is also unhybridized. They have nothing to do with hybridization. Only sigma bonds are taking part in hybridization, and only sigma bonds are responsible for shape. So what I am going to tell you? Just try to understand what I am going to tell you. This is being carbon, this is being carbon, and if I say this is being sigma bond, this is also being sigma bond, and this is also being sigma bond, only sigma bond are going to decide what? The shape. So the shape is decided by whom? Shape is linear, and shape is decided by whom? Just to let me know in the chat section. Shape is linear and decided by sigma bonds. Decided by sigma bonds only. If I say, do pi bonds having any role? Do pi bond having any role in this shape? No, pi bond doesn't have any role in the shape. 180 degree, and this is linear in shape. Linear in shape. Pi bond has no role. Pi bond, these pi bonds, they do not have any role in the shape determination. Pi bonds do not play any role in the shape determination. No role in the shape determination. Pi bonds do not have any role in shape determination. I hope this much is clear to each and everyone. Do let me know in the chat section that yes, sir, we got it. We got it. Everyone do let me know that yes, this much is clear to all of you. I can see in the chat section, everyone, don't sit idle. Take participation in the chat section. I want to see that everyone. Are you getting it or not? Killer science. Yeah, that's really awesome. I can see Murugabil Kandan. Yes, that's really awesome. Now see everyone. Just see to it. This I have told you. This I have told you. Now, preparation from calcium carbide. Have you heard the name of Taj Mahal? Everyone do let me know. Have you heard the name of Taj Mahal? Everyone do let me know. Have you ever visited Taj Mahal? Now, from Taj Mahal, we are going to prepare acetylene. Today, we are going to prepare acetylene from Taj Mahal. Taj Mahal. Wah, Taj, wah. Taj Mahal to acetylene. Is there anyone who is going to help me how I am going to prepare acetylene from Taj Mahal? Any guesswork? Any guesswork? What is Taj Mahal actually? Any guesswork in the chat section? I want to see, is there any guesswork? King Live, do let me know that how can I prepare acetylene from Taj Mahal? I want to see. Any guesswork, kids? Taj Mahal. You know Taj Mahal. And I'm going to prepare acetylene from Taj Mahal. Any guesswork? Any guesswork? Calcium carbide. Yes, Taj Mahal is calcium carbonate. This Taj Mahal is calcium carbonate. Let me tell you, kids, calcium carbonate, CaCO3. It's white. So let me take white, CaCO3. Calcium carbonate. Calcium carbonate. Now, if you are going to heat this calcium carbonate, what will happen? Kids, do let me know. If you are heating this calcium carbonate, what you are going to get? If you are going to heat this calcium carbonate, Taj Mahal is made up of calcium carbonate. Kids, do let me know, if you are going to heat this calcium carbonate, what you are going to get. Killer Science is saying CaO. Kids, nothing you will get. Nothing. Nothing you will get. Nothing. Nothing you will get. Ask me why. Nothing we will get. Just do let me know why we are not going to get anything. Is there anyone who is going to let me know that nothing we are going to get? Killer Science said calcium oxide and carbon dioxide. No, kids. This calcium carbonate is highly stable. Do remember, always remember, this calcium carbonate is highly stable. That's why Shahjahan has used this calcium carbonate. Kids, always remember, if by getting some heat, if Taj Mahal is going to get destroyed and it is going to convert into calcium oxide and carbon dioxide, then think about Shahjahan. Was he fool? Was a fool guy? No, he was intelligent. The earlier members, they were really intelligent. So you're not going to get anything. Then why you said calcium oxide? Now see, let me tell you what's the reason what's the reason behind it. Just see to it. Everyone try to understand. If you are going to heat this calcium carbonate, CaCO3, up to how much? What temperature? If you are going to heat calcium carbonate up to 1200 degrees Celsius, this much of temperature. Killer Science, your answer was correct. But have you ever thought like that? This much of temperature, see, 1200 degrees Celsius. Is it very small temperature? Small amount of temperature you are going to give, or huge amount of temperature is required? Do let me know. Now, this is not sharp temperature. You can say it ranges from 900 degrees Celsius to 1300 degrees Celsius. But then also it's a huge range. It's a huge range, isn't it? High amount of temperature, high heat or high temperature is required. Yes, then definitely it is going to break into quicklime, it is going to break into quicklime CaO plus carbon dioxide. This temperature has been mentioned in S block. In your NCERT, you will see that in NCERT S block, this temperature has been mentioned, and from the last 2 years, the NTA is asking questions on blast furnace and temperature based question. Do you remember? Do you remember? Are you agreed or not? In the chat section, do let me know. Are you agreed or not? Last year, NTA has asked one question from the blast furnace, and that was temperature based. And this year also 2023, NTA has asked one question based on temperature. So temperature is very, very important. So do remember, very high amount of temperature, then you are going to get quicklime. Quicklime. Now, when this quicklime is going to come in contact with CaO, now this quicklime is deliquescent in nature. You know deliquescent? Is it deliquescent? No, it's not deliquescent. It is hygroscopic. So there are two terms. One is deliquescent and one is hygroscopic. Do you let me know? Yes, anyone? Is there anyone who can tell me what's the difference between deliquescent and hygroscopic? I am saying this quicklime is hygroscopic in nature. Hygroscopic in nature. Hygroscopic nature means, let me tell you the difference. Deliquescent absorbs moisture from the atmosphere, and deliquescent also absorbs moisture from the atmosphere. Both the deliquescent as well as hygroscopic, they absorbs moisture from the atmosphere, but deliquescent gets dissolved in it and it loses its nature. But hygroscopic, they do not dissolve in water and they never lose their state. Absorbs moisture from the atmosphere, but does not lose its, but doesn't lose its nature or state. Now, if you bring carbon in front of it, 3 moles of carbon. Now, just do let me know what you can see. What you can see, do let me know that this calcium will react with carbon and you will get carbon monoxide. Right now, just try to keep it in your brain that you will get carbon monoxide and calcium carbide, CaC2. Now, if you are able to understand this calcium carbide, do let me know what type of bonding is present in calcium carbide. My question to you is, what type of bonding is present in calcium carbide? Do let me know, everyone. What type of bonding? Yes, everyone. What type of bonding is present in calcium carbide? My question to you is, what type of bonding is present in calcium carbide? Everyone. Calcium carbide CaC2 is having what type of bond? Everyone, do let me know. I want to see in the chat section. That's a simple question, kids. Hey everyone, this is really simplest question. What type of bond is present in calcium carbide? This is the most important thing and that is required. I want to see very strong. I'm not asking it is strong or weak. I'm just asking what type of bond, covalent bond, ionic bond, metallic bond, what type of bonding is there? Aarti is writing ionic. Kandan is writing ionic. This is the most important question, that in calcium carbide, what type of bonding? So here I am writing the question. Everyone try to understand and try to give me the answer. What type of bond? What type of, this is a question. What type of bond? What type of bonding in calcium carbide? In calcium carbide, I want to see the answer. So somebody is writing ionic bond, rest are writing covalent bond. Kids, No one is writing the correct answer. First is being ionic bond. Everyone try to participate. Ionic bond, covalent bond, 100 and times, more than 100 times you must have studied your NCERT, but no one is going to let me know what type of bonding is present in calcium carbide. I want to see, kids. So the answer is both covalent as well as ionic bond is present. Ionic bond is present. This is the correct answer, kids. If you don't know this thing, kids, examiner is going to kill you. Examiner is going to kill you. Now see, everyone see. Just see to it. Calcium carbide is like this. Ca, ding 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 ding, carbon, ding 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 ding, carbon, ding 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 ding, ding 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 ding, ding 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 ding. So can you see, everyone? Calcium has lost 2 electrons, so 2 plus, 1 negative, 2 plus, minus 1, minus 1. You can see this bond. What the name should I give to this bond? This bond is known as, these two bonds are known as ionic bonds. And these bonds are known as covalent bonds. So if anyone is going to ask what type of bonds are present in acetylene, so never get failed. And this is the gas which is used for ripening of fruits. Calcium carbide. Actually, calcium carbonate is not going to ripe the fruits. It's acetylene gas. But once you are adding calcium carbide to water, if you are adding calcium carbide, this calcium carbide to water, what you are going to get? See, if you are going to add this calcium carbide, ding 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 ding, ding 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 ding, so patch, negative to positive. Now water, blue, water is being like this, OH delta negative, H delta positive, H delta positive, OH delta negative, zoom back. So what you are going to get? Hey everyone, see to it. Zup. What do you have got? Acetylene gas. You have got acetylene gas. You can see very clearly. CH, triple bond, CH minus calcium hydroxide, CaOH whole twice. And this is the gas which is used for ripening of fruits. Is it clear to your brain? Now, a thing arises that how we can convert this smallest alkyne. This is being a smallest alkyne. This is being what? This is being your smallest alkyne. Now, question arises, is it possible to convert this smallest alkyne into bigger alkyne? Unsymmetrical as well as symmetrical alkynes, how to convert it? See, how to convert this alkyne. Just see to it, everyone. See to it. Suppose if I am provided with acetylene gas, CH, triple bond, CH, and examiner has given you convert it into butane, CH3, CH2, C triple bond, CH. This is but1ine. Do let me know what reagents should be used. Any guesswork? We are supposed to convert this acetylene should be converted into butane 1 or but1ine or butane. Is there any guesswork? Anyone? Hey, any one of you, do let me know. Now see, this is having 2 acidic hydrogen, one acidic hydrogen, another one acidic hydrogen. Its pK value is 25. So these 2 hydrogens are being acidic hydrogens. Now, you know that when acid comes in contact with base, it will show reaction. So bring one sodium, bring one equivalent of sodium in front of it, just one equivalent. Why only one equivalent? One equivalent only. If you are bringing more than one sodium, then it will react and this will react. Both are being acidic hydrogen, both will get consumed. So one equivalent of sodium you have to bring, and now you are going to get, see everyone, CH triple bond CNA. This is being delta negative and this is being delta positive, or we can say negative positive because this bond is being ionic. Na, this is negative and this is being positive. Monosodium acetylide, monosodium acetylide, monosodium acetylide. Now, can you see this is a very, very strong nucleophile? Now, what you're supposed to do, this is very, very important thing. Just do only one thing. One step is required over here. Bring, see, this is having 2 carbons and this is having 4 carbons. So bring CH3, CH2, halogen. This X can be either chloride, bromide or iodide, but can't be fluoride. If this X is being fluoride, reaction is not going to take place. Now, what is going to happen? Everyone see, this Na plus and this X negative will eliminate out. This is known as nucleophilic substitution reaction, NSR. And you will get this alkyne. Still, this alkyne is having one acidic hydrogen. One acidic hydrogen. Everyone, do let me know. Till now, is it clear? If yes, show me the thumbs up. Yes, this is for class 11th as well as 12th as well as droppers. This is given in your NCERT class 11th only. Yes, Rama, I think you are new. Rama, if you are new, join this channel, subscribe it and smash the like buttons. Now, everyone, very good. Now, if examiner is asking how to convert this alkyne into symmetrical higher alkyne, this is unsymmetrical higher alkyne, this is your unsymmetrical higher alkyne. Now let's see how to convert into symmetrical higher alkyne. See everyone, see, and just try to understand and try to think how to convert. Everyone, apply your brain. If we are provided with this acetylene and examiner has given to convert this acetylene into this alkyne, symmetrical alkyne, see, butene. Now apply your brain. Everyone, apply your brain so that you can understand. This is smaller symmetrical alkyne and this is butene, higher symmetrical alkyne. This is your higher symmetrical alkyne. Everyone, try to understand and try to respond, please. Apply your brain. I want to see in the chat section because examiner will give you reagents. Examiner will give you reagents and he will ask you what reagents can be provided. Everyone, do let me know. Now, what you are supposed to do, see kids. Everyone, see to it. Use Na, 2Na or X's, Na in X's. What you will get? Na, C triple bond C, Na. What is the name? Name is disodium acetylide. Disodium acetylide. Remember this name, very, very important. Now it is negative, negative, positive, positive. What you are going to do? See, In this, we are having two methyl groups extra. So what to do? Wow, this is Bidhajanani. Really awesome. I'm coming to that point. So add 2 moles of CH3X. This X once again can be chloride, bromide, or iodide. One more thing, you can come like this also. See, just like Bidhajanani said, there is one more approach by which you can come. You can use NaNH2. This is alternative method. Soda amide. This is known as soda amide. Na positive, NH2 negative, and this is known as soda amide. Now, if you are using soda amide, kids, what is going to happen? Everyone see to it. This H plus and this is being carbon negative. So this sodium will come over here and this NH2 negative will take this proton and it will form ammonia. It is going to form ammonia gas. It will form ammonia gas and same will happen over here. Na NH2 negative and a positive NH2 negative, this proton will be taken up by this and ammonia will get eliminated and you will get this answer. Everyone is able to understand both the two type methods can be used. Either you can use this method or you can use that method. Both are equally good. PDF of this session you will get on Telegram. Telegram link. Anyone is having Telegram? If you are on Telegram, Srinath, you will get on Telegram, right? I will send it over there. Now, kids, everyone, see to it. Now, if your examiner is asking one question, that you are provided with CH3, CH2, C triple bond CH. What's its name? 1, 2, 3, 4. But1-ine. But1-ine. And examiner said, convert it into hexyne. So what you are supposed to do? Hexyne. Do let me know in the chat section. Everyone, do let me know in the chat section that what you're supposed to do. How will you get the answer? I want to see in the chat section that are you able to give the answer or not. So it will take too much time to write in that. So I'm going to write on the board. You just try to think that the same thought were coming to your brain or not. So let me react it with. Either sodamide NaNH2 or sodium. Should I use one equivalent or excess? Doesn't matter. Whatever the amount you are going to take, any amount you can take. Why any amount? Any amount you can take because there is only one acidic hydrogen. This side no acidic hydrogen. So this will get converted into CH3, CH2, C triple bond CNA. Now just focus over here. 4 carbons are in this chain and hexyne is 6 carbons. What should be treated to get the answer? To let me know, everyone. Let me see to it what think X is of sodium and CH3X. Akanksha is saying CH3X, 2 moles of CH3X. No. Hey, Akanksha saying your answer is wrong. See, this side is no acidic hydrogen. Only one acidic hydrogen is there. You got your answer is wrong. Only one acidic hydrogen. Akanksha saying only one acidic hydrogen. So your answer is wrong. Others, I am waiting for your answer. No one else is going to give the answer. Yes, Ramesh Konda Murugu. Yes, Ramesh, your answer is absolutely correct that we have to use CH3, CH2, X because this X negative and carbon delta positive, what is going to happen over here? This Na positive and this X negative will eliminate out. And this carbon will form a bond. This carbon is going to form a bond with this carbon. Zim, 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 tick, 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 tick. Zim, 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 zim. Everyone is able to understand? Is everyone able to understand? Yes. So, everyone got it. Now, from vicinal halide, vicinal, or we can say vis, V-I-C, vis halide. It can be given like this also. Now, what are vicinal halides? Anyone? Vicinal halide. Suppose I am writing vicinal halide, it should come to your brain. CH2X. CH2X. This is known as vicinal halide. If on same carbon two halogens are present, we will say gem halide. If different carbon, adjacent carbon they are present, we will say vicinal halide. Now in front of this, you have to bring what? Alcoholic KOH. Bring KOH alcoholic. KOH alcoholic. K positive, OH negative, alcoholic plus heat. Now see what is going to happen. Everyone try to focus over here. Everyone see to it. See, this is being delta negative, this is being delta negative, and this is being delta negative, and this is being delta positive. Now this K positive will withdraw electron as well as halide, and it will take away this X negative. Now carbon will develop positive charge. Now OH negative is a base, as well as it is a nucleophile. Now which role it has to play? OH negative is base as well as nucleophile. What do you think? Which role it will play? Anyone in the chat section? From the chat section, anyone is going to let me know which role it is going to play. Remember that first preference always should be given to base. First preference when an entity can behave, or is having ability to behave as both, always give first preference to base, because acid base neutralization process is fast process. Acid base neutralization. So this OH negative will take one proton from here. So once this proton has gone through acid base neutralization, it will develop negative charge. What will you get? Negative positive, a one bond will get formed. So new bond formation has taken place. You have got CH CHX double bond CH2. Now you can see this halogen is having lone pair, and there is one pi bond. Its lone pair will participate in resonance. This lone pair will take participation in resonance. So lone pair is taking part in resonance. So what is going to happen if it is taking part in resonance? What problem is going to arise? See kids, what problem is going to arise over here? Very important problem is going to arise over here. So this lone pair is going over there, and this is going over there. So this has lost, this X has lost one electron, and it will look like this. Double bond CH2 negative, and this X positive. These two are resonating structures. If you don't know this point, you won't be able to understand. This A and this B are resonating structures. A and B are resonating structures. A and B are resonating structures. So which one is the true structure? Out of A and B, which is being true structure? Do let me know. This A is true structure or B is true structure? Everyone do let me know which one is the true structure. acid base neutralization. This was neutralization. Let me write it down. Till then you can think which one is true structure. Some are saying A is true structure. None of them is being true structure. Do remember that none of them is being true structure. Let me tell you. This is the very, very important point. None of them is being the true structure. See everyone. See, this is very, very important point. One is this structure. One structure is like this, CH2 double bond CHX, and another structure was like this, CH2 negative CH double bond X positive. Neither A nor B, none of them is being true structure. They are being resonating structures or canonical structure. Do remember everyone, these are being resonating, or we can say canonical structures. Canonical. So how to see which one is the true structure? See everyone, sometimes this double bond, see this is pi bond, this is being sigma bond, it is looking like sigma bond. Here this is having pi bond and this is pure sigma bond. Although it is having sigma and pi both, it is having sigma. So none of the two structure is explaining all the physical and chemical properties, and we need, see, the combination of both, combo or both, A and B's combo. See how to draw A and B's combo. See everyone, CH2 CHX, and this X is having delta positive and this was having delta negative, and this this is the very, very important point. Neither this nor that is single bond. The single bond has developed what? Everyone write down in the chat section. This single bond, if I talk about, because I was interested in this only, I was interested in this bond. Is this pure single bond or single bond has developed partial double bond character? Do let me know. Is this pure single bond or the single bond has developed? This is known as resonance hybrid. Resonance hybrid, the true structure, resonance hybrid, or we can say true structure. This structure is giving all the information about this compound. So single bond has developed partial double bond character. This single bond has developed partial double bond character, and always remember that to this bond I always say, what? Is there anyone who is going to let me know? This bond I always say that whenever on the sp2 hybridized carbon of olefin means carbon double bond, olefin means carbon double bond. So this atom is known as vinylic atom. Vinylic, this is very, very important point. Vinylic atom. If you remember, once I have told you this is the captain of the ship. You must have seen Titanic movie. Have you ever seen Titanic movie? Do you know about Titanic movie? This is, let us suppose, Titanic. This is being Titanic. Let us suppose this is being Titanic. And who was the last one not to leave the ship? Let us suppose this Titanic is being carbon. This carbon is being Titanic. This is Titanic. Who was the last one who got captain of the ship? Is the last one to leave the ship. Captain of the ship. So vinylic atom, I always say captain of the ship. In my dictionary, captain of ship. So it's looking like single bond, but it is having partial double bond character. That's why this bond is very, very strong. This bond is being very, very strong bond. Very, very strong bond. It's looking like single, but it's not single. Single bond has developed partial ionic character. So it is not going to leave easily. So see, from where to where I have reached now. If I talk about NCERT, in NCERT it is written in NCERT, it's written that if you want to cleave this bond, if you want to break this bond, alcoholic KOH will not work. Alcoholic KOH is not going to work. What you are supposed to use, if you have ever seen NCERT class 11th part 2, the reagent mentioned over there is what? NaNH2. Now alcoholic KOH is not going to work. Soda amide you have to use. You have to use soda amide. Soda amide. Now soda amide plus heat. Plus heat. Soda amide plus heat. Now you will say, sir, why soda amide is being strong base? I will let you know. I will give you the explanation of it, but let me complete it. This chloride along with electron will go along with sodium. It will form NaCl, and this NH2 negative, amide negative, will take one proton, and you will get acetylene, and this will form ammonia. Now see what I am telling you. In the NCERT, they have not given the explanation. That's why people used to say that NCERT used to write in between the lines. Now see, try to understand that if I write KOH, then K positive, OH negative, this is the base part. If I am writing NaNH2, Na positive, NH2 negative, so we have to decide which is being a strong base. This OH negative is strong base or NH2 negative is strong base. We cannot find out. So these are conjugate bases. Let us suppose one way directly we can see which is being a strong base. This oxygen's electronegativity is 3.5 and this is just 3. So who is in strong need of proton? Its electronegativity is just 3 and its electronegativity is 3.5. This is strongly needed one proton, or you can do one thing, that add proton to both of them. Once you are going to add proton to both of them, they will form conjugate acid, ammonia. Now you can see which is more acidic. Definitely water's pKa is 15.7 at 25 degrees Celsius, and this is 35, and this is 35. So its pKa value is less. The one with less pKa, if stronger acids form weak conjugate bases. Do you remember? Stronger acids form weak conjugate bases. This point you know very well. Stronger acids form weaker conjugate base. So weaker acids will form stronger conjugate base. So NH2 negative is stronger conjugate base. Is it clear? This is being stronger conjugate base. So that's why it is being used. Stronger base. Is it clear to all of you? Have you got the explanation why NCERT is going to use? Now, I'm going to give you one question of AIMS. Should I give you one question which has been asked in AIMS twice and in IIT 4 times? By changing a little bit, they have asked 4 times in IIT. Is everyone ready? Now see what question has been asked. See to it, everyone. See to it. Question is, your question is, how many moles of how many moles of, how many moles, how, and leave it. How many moles of NaNH2 will get used, will get used for following conversion, for following conversion, conversion, following conversion. Now conversion is, it's given like this: CH2 Br, CH2 Br, this compound. It is also possible they will not give you the structure, they can even give you the name of this compound. What's the name of this compound? Anyone? Name of this compound? It is known as ethylene bromide. Now once again, it is a misguiding name. Why it is misguiding name? Ethylene, just focus over here. It is in, but there is no double bond, so take care of this name. This is journal name, and journal names are really very confusing. Ethylene bromide is reacting with NaNH2. We don't know how many moles of NaNH2 are going to get consumed, and we are supposed to prepare compound like this, NaC triple bond CNA. Options, let me give you options. Option A 3, option B 4, option C 2, option D 6. So what is the correct answer? Try to find out the correct answer. I'm waiting for your answer. Yes. Sunlight. Oh, your name is Sunlight. I was thinking that sunlight is required. I was thinking like sunlight is required. Your name is Sunlight only. So what's the answer? I'm waiting for your answer. Everyone sit with pen and paper and try to understand it. What's the answer? So majority of students, they are going for C. Akanksha Singh is going for B. Akanksha Singh is going for B, and Sunlight is also going for B. So 50-50, it's like Britannia 50-50. Some students are saying B and some students are saying C. Let's see what's the correct answer. You can at least discuss on the chat, in the chat section only. Hey everyone, try to tell others what should be the correct answer. At least you can discuss in the chat section. And everyone, those who are new, hit the like button, smash the like button, kids, make it 100 at least. Your HSP Baba is saying, make it 100. It's already 82. Priya Verma, Vincia, Hiller Science, Kandhan, Priyanka, everyone is going for C. Let me see. Everyone try to explain to each other so that they can reach to the correct answer. Help each other. A friend in need is friend indeed. So Sagar is also going for B. So let me tell you what's the correct answer. The correct answer is being B. So see kids, B is the correct answer. Now let me explain it. Why? For what B is being the correct answer? See everyone, try to understand it. Everyone, this is CH2Br, CH2Br Now, NaNH2, let us suppose Na and NH2. Na is having positive charge, NH2 is having negative charge. So this negative one will take one proton from here, zoom, 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 zoom. And this will take one bromide from here, zoom, zoom. So what they will form? What they will form, kids? It will form ammonia minus NaBr. And this will look like, yes, CHBr double bond CH2, vinyl bromide. Its name will be vinyl bromide. Vinyl bromide. So 1 mole of NaNH2 got consumed. Now see, once again 1 more mole of NaNH2 will come. Na positive, zoom, 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 NH2 negative, sup, 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 ding, 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 ding. Now see, this Na will take one bromide, here positive charge will develop, and this NH2 negative, amide negative will take proton, and here negative charge, negative positive will form bond, C triple bond C, H, H. So 1 more mole of NaNH2 got consumed, 2 moles got consumed, right? Now, here are 2 acidic hydrogens. You see, here are 2 acidic hydrogens. Even the examiner can ask one more question. Let me tell you what he can ask. These 2 reactions are dehydrohalogenation. This one is dehydrohalogenation. This one is also dehydrohalogenation. Why the term dehydrohalogenation for the first 2 reactions has been used? Yes, kids. Is there anyone? The first 2 reactions are what? Dehydrohalogenation. What does it mean? Dehydrohalogenation. Dehydrohalogenation means loss of halogen and hydrogen. That means loss of HX. But kids, now see, very, very important question. NH2 negative will come over here and this will take away its proton. NH2 negative will come over here and it will take its proton. These 2 reactions are what? Is there anyone who can let me know? These 2 reactions are known as acid-base neutralization, because this is acid-base neutralization. So acid-base neutralization is taking place. Acid base neutralization reaction. Is it clear? So these 2 reactions are acid base neutralization. So Na positive will form a bond with this carbon. Na positive will form bond with this carbon. That's why you have got disodium acetylide. Disodium acetylide. I hope that this point is clear to each and every one. Disodium acetylide. Kids, do let me know. Till now, it's clear to each and everyone why 4 moles of NaNH2 has been used. If you are able to understand, show me the thumbs up. This is your class only, and 87 likes have been reached to 87. Make it at least 90, not 100, then at least make it 90. Wow, Akanksha saying sunlight, Priyanka, Kandhan, really fantastic, fantastic. That's really awesome. Now, see what we are going to discuss now. Physical properties. If you see your NCERT, what does it mean, physical properties? If anyone is going to ask, alkynes are solid, liquid or gas, do let me know. Alkynes are solid, liquid or gas? Everyone try to understand, try to answer it. Alkynes are what? Alkynes are solid, liquid or gas? Do let me know. Alkynes are first option solid, second option liquid, third option gas. Let me give you fourth option, all of these. Look, bye. All of these. I have given 4 options. See, I have given even all of these. Everyone try to find out the answer. Even I have given all of these. So, wow, it depends. Kandhan M, Aarti, that you kids are really, really very intelligent, that it depends. So, all possibilities are there. So, everyone try to understand. Smaller members are gas. First three members are gas. First three members are being gas because they have very less number of electrons, so less van der Waals forces of attraction, so they are being gases. Next eight are liquid, and then they are higher members are being solid. So this is the correct answer, and definitely you got full marks in this. Now let's go for chemical properties. And the chemical properties, let me tell you, if somebody is asking who is going to react with Tollens reagent, have you heard the name Tollens reagent? Anyone? Do let me know, have you heard the name Tollens reagent? CH triple bond CH, one is being CH3 CH2, C triple bond C CH3, one is being CH2 double bond CH2, one is being CH3 CH3. Out of these four, which will react with Tollens reagent? This question is, out of these four, let us suppose A, B, C, D. Who will react with Tollens reagent? Anyone? Ammonical AgNO3, ammonical silver nitrate, AgNO3. So who is going to react with Tollens reagent? All four? None? Or what's your answer? All four will react? Any one will react? None of them is going to react? All four will react. Is there anyone who is going to give me the correct answer? B. One answer has come. B. B. Everyone is going for B. Jashri has gone for A. Jashri has gone for A. One student has gone for A. Rest are going for B. Now see. Only this one will react. This one with AgNO3 ammonium hydroxide. AgNO3 ammonium hydroxide, only the first one is going to react, neither second nor third. They will not show any reaction, no reaction. This is having acidic hydrogen. Terminal one is being acidic hydrogen. Now, actually Tollens test, in Tollens test, we are going to get silver mirror. You will study when aldehyde and ketones you are going to deal with, you will study that Tollens test, silver mirror is produced. But in case of alkynes, Tollens test is possible. It will take place, but you will not get silver mirror. You are going to get white color. This is a very, very important thing. You will get white PPT. Do remember, Ag, C triple bond C, Ag, white precipitate you will get. No silver mirror, no silver mirror, no silver mirror, kids. A white PPT will be produced, and this is also known as positive test because the color is produced. In organic chemistry, if the color is produced, that becomes the most special reaction because it is a distinguishing test, and this is the only test which is going to distinguish these alkynes from alkenes and alkanes. Alkene, alkyne, alkene doesn't give this reaction. Alkanes do not give this reaction. And this is alkyne but not having what? Alkyne but not having. Alkyne without acidic hydrogen. So what are acidic hydrogens, kids? Only these hydrogens which are on terminal triple bond. Terminal triple bond are acidic hydrogens. So terminal triple bond are being acidic hydrogen. Is it clear to all of you? Terminal. Now question arises. If we are having a compound like this, if we are provided with a compound like this, CH3, CH2, CH2, C triple bond CH. Now, if we react it with AgNO3 ammonium hydroxide, AgNO3 ammonium hydroxide, this is known as ammonical silver nitrate. It can be also given as ammonical silver nitrate solution, silver nitrate solution. Now, everyone do let me know whether this is going to give white PPT or not. This reaction will give you white precipitate or not. Do let me know, everyone. I'm waiting for your answer. Is the reaction is going to give you white precipitate or not? I'm just waiting for your answer. Yes, because it is having one acidic hydrogen, one terminal hydrogen, that is being acidic hydrogen, So yes, you will get white precipitate. Definitely you will get white PPT of CH3, CH2, CH2, C triple bond C Ag, white precipitate, white PPT. Now, the most important thing, how will you distinguish? Now see, two questions arises, two questions. First, let me tell you those two questions, very, very important two questions. Let me tell you, how will you distinguish? How will you, question number one, how will you distinguish ethane CH3 and ethene? Do let me know. How will you distinguish ethane and ethane? Option number one, AgNO3 ammonium hydroxide. Option number two, CH3 MgBr, zinc and water. Option number three, Br2 water. Option number four, all of these. Everyone, you have to answer it. That is the most important thing. Everyone, try to answer it. Silver mirror is not formed. Why? Kids, let me tell you, one kid is asking why silver mirror is not formed. Tolerance test is being redox reaction. Tolerance test, when you study aldehyde and ketone, tolerance test is being redox reaction. But here acid base reaction is taking place. That's why here silver mirror will not form, because silver mirror, in case of silver mirror, silver gets separated, Ag, that is Ag. But here it's not Ag, here it is Ag plus. Silver mirror is being Ag, but here it's just Ag plus. If you see, this is being Ag plus. It's not silver mirror because it has not undergone reduction, because this is not redox reaction, this is acid base neutralization. What's the name of that kid? Aghalya. Aghalya, you got it? Aghalya SM. Aghalya SM. Now, what's your answer of this question? Second. So, Gamer is going for second, Naina is going for second, Murugaval is going for second, everyone is going for second, Kundan is going for third. Only one answer is being correct, that is being third one. Others are wrong. Should I let you know why you are wrong? Why your answer gone wrong, kids? Should I let you know? Whenever thing is written, how will you distinguish? Whenever it is mentioned distinguish means either color should get produced or some fume should get evolved with some smell, characteristic smell. Whenever this word is used, 99.9% means color should get produced, color should get produced, color must be produced. Now, or color either must be produced or color should go away, fade away, change in color. Either color must produced or change in color, change in color, change in color, or color should get disappear. Change in color, color must be produced or color should get faded away or decolorize or decolorization or decolorization. Any of these things are taking place. That means, see, bromine water. Bromine, what is the color of bromine water? What is the color of bromine water? It's either reddish brown or orange red. Either of the color. Either we can say reddish brown. Its color is either reddish brown, or orangish red. Now see, one is this, one is this. How many things? Ethane and ethene is given. Now see, let me explain it. Everyone see, let me tell you how. There is one flask, there is another flask. Two flasks are there. This is flask number 1 and this is being flask number 2, and some liquid is placed over there. These flasks are filled with liquid. These flasks are being filled with liquid. Same color, colorless. And the label of these two liquids got removed in the raining season. That label got removed. They have told you one is having ethene and one is having ethane, but we don't know which one is having ethene and which one is having ethane. You must have played in your childhood. See the game. When we were kid, we were taking something in our hand. Let me tell you. Suppose this coin. Now, what we were doing? See, this is one coin I have taken over here. See, now gil 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 shum, gil 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 shum, gil 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 shum, gil 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 gil. See, it is there. Gil 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 gil. Wait, where it's going? Once again I have to do. This is having over here. Gil 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 gil. Now, which hand, the right one, this one is having or this one is having? Do let me know, everyone. Which one is having? Do let me know which one is having the coin, this one or this one. So one is in front of you, one is behind. The behind one or the front one? The front one or the behind one? The front one or the behind one? Do let me know. This front one is having or the behind one? So 50% are saying front one or 50% are saying behind one. See, in the front one there is nothing. In the behind one, the coin is over here. So we cannot see with our eyes. So like that, which flask is having ethene and which flask is having ethane? Now try over this. Everyone, just try over here. Which one is having ethene and which one is having ethane? Do let me know. In which flask? Question is in which flask ethene and in which flask ethane? So how to do it? Should we go to drink it or should we do something else? Now see, we have to add bromine water. If we have added bromine water and the color is not getting changed, suppose this is reddish brown. If suppose the color of this flask is reddish brown, what does it mean? What it is indicating? After adding bromine water, the color is remaining like this. Color of bromine is not getting changed. Color of bromine doesn't decolorize. Color of bromine doesn't decolorize. What does it mean? What does it mean? It means that this compound is saturated. This has indicated that this compound is being saturated. And if this compound is saturated, this compound is saturated, and that means that it indicated that this is ethane. This is being ethane. It's clear that this is being ethane. C2H6 confirmed. Now if you are going to add bromine water to it, this bromine water will get decolorized. Bromine water will get decolorized. Everyone got it? That indicates that this indicates that this is being ethane. Ethane confirmed. Everyone got it? So this is the thing, how to distinguish. Is everyone satisfied? Have you got it or not? Do let me know, everyone. Are you able to understand? If yes, show me the thumbs up. And likes have been reached up to 93. Make it 1 century. I want to see 100. Okay, that everyone is able to understand. Now see. Everyone see to it. Addition of HX. We are going to deal with chemical properties of alkynes. Is everyone ready for the chemical properties of alkynes? Break. Srinath, I will give you a break, but not right now. Let me complete it. It's not a lengthy class, so no need of break is there. Let me complete it. No need of break. Okay. Now, so addition of HX. See to it, everyone. If I am going to deal with, let us suppose acetylene only, CH triple bond CH, and I am going to add HCl. Now this is being symmetrical. Symmetrical means whatever is on right hand side, same is on left hand side. Symmetrical. So any side you can shift this pi one. Let us suppose delta negative, delta positive, and HCl is being delta positive and delta negative. What is going to happen, kids? This negative part will come and join to this carbon, and this positive part will come and join this. Now what you have got? We have got C double bond C. Already it was having H. So this side we have got Cl, and this side we have got H. Now is it symmetrical or unsymmetrical? This is symmetrical or unsymmetrical? Do let me know. It has become unsymmetrical. Now the question will come from here only. That if we are going to add HX to it, so two possibilities will arise. Two possibilities. See why? Two possibilities. HCl, this is H positive. This will go and attack first because it is having lone pair. It is having lone pair. So this is being nucleophile. Nucleophile means electron rich or nucleophile. Electron rich entities are being nucleophilic. So the electrophilic part will go and attack. This is possible that this can attack on this carbon, first attack, or it can attack to that carbon, isn't it? Yes or no? Two possibilities are here. Everyone, try to understand. This is going to be the most important point, and you have to focus over here. If you're going to miss this point, you won't be able to answer it. So are you ready? So two possibilities are there. So let me write down both the possibilities. If this H positive is going to attack at this carbon, it has attacked this carbon, so it will convert into CH. Already one H was there, one more this H has added up over there, and this was the chlorine, this was the chlorine, and on that carbon double bond CH, H positive charge has created. Let's suppose this is X carbocation. Let me name it X carbocation. This is being X carbocation. If this has attacked over there, that will convert into CH3 and CHCl positive. This is being Y carbocation. Y carbocation. Could you please help me which carbocation is being more stable? This is the most important point, and the examiner will ask from here only, out of X, which X and Y, which is being to be more stable carbocation. Kids, out of X and Y, which is being more stable carbocation? This is the most important point, and examiner will ask from here only, and the question arises whether this X carbocation is being more stable or the Y carbocation is being more stable. So Killer Science is saying X is being more stable. King Live is also going for X. Priya Verma is also going for X. Aarti is also going for X. So everyone is going for X. Now, your examiner will give you big zero, big zero, big zero, because Y is being more stable. This is being more stable. Everyone got failed. More stable. So, should I tell you why you got failed? Should I let you know why you got failed? Should I let you know why you got failed? You have not think about resonance in your brain. Inductive effect was there. Am I right or wrong? I'm a great psychologist also. My psychology is being very, very strong. In your brain, you have just applied inductive effect. You have not gone through the path of resonance. Am I right or wrong? So always remember that. Apply resonance first. Rahis, if you're not applying this order, you are going to get failed. So not only 1, 2 or 3 students, majority of these students, they got failed. Only one student has given the correct answer. I don't remember the name, but yes, only one student has given the correct answer. Rest of others got failed because your brain was thinking about inductive effect. But this is the order. Rahi is resonance, hyperconjugation. Now see, this carbocation is just having minus I. This is getting destabilized by minus I. See, minus I is applied over here. Minus I, minus I, minus I, minus I. So minus I, charge is increasing and stability is decreasing. But see, by minus I, charge is increasing, but this is having lone pair and this is having vacant orbital. Lone pair is present in 3p and vacant orbital is 2p. So 3p pi 2p pi back bonding is there. What is there? Stabilized by 3p pi 2p pi back bonding. 3p pi 2p pi back bonding. So this is stabilized by resonance. Stabilized by resonance. Now, if this is stabilized by resonance, this is being more stable, more stable, more fond, more stable, more fond. Let me move towards the next page. And more stable, more formed. See, what was the carbocation? Carbocation was like this, CH2. Let me see to it. Carbocation was where the carbocation has gone. This was the carbocation. I think something is missing over here. See, it is not CH3. Yeah, it's CH3, right? CH3, CH positive, Cl. CH3, CH positive, Cl. So this carbocation is stabilized by resonance. Carbocation stabilized by resonance. Now kids, you will say, so where is resonance? It was the back bonding. There was just the back bonding and you're talking about resonance. So kids, let me tell you, two atom resonance, that is back bonding. That is back bonding. Let me tell you, back bonding. I think that everyone is able to understand that its lone pair is giving help. This is having right now 8 electrons, that is having 6 electrons. Once it is donating electron, it will look like this. It will look like this, Cl double bond CH. This is having positive charge, and this is CH3, and these two are resonating structure. These two are resonating structures. So these two are being resonating structure, and this carbocation is stabilized by resonance. Now ultimately chloride will attack over here. This is having 6 electrons, so chloride will attack on this carbon, and this is going to be a product. So product will be CH3 CH Cl Cl, gem halide. So answer will be gem halide. And those who were saying that this is more stable, they must have got vicinal halide. So examiner will ask you that vicinal halide is going to be the major product or gem halide is going to be the major product. Let me tell you how the question will be asked. See how they will ask you the question. The question is, find out the product. Find out the major product in the following reaction. And the reaction is CH triple bond CH plus HCl excess now one option is being vicinal halide, one answer being gem halide, so two options I have given just to let me know what's the answer. What's the Lakshmi Narayan? Can't give break. Why you want 5 minutes break, Lakshmi Narayan? Why you want 5 minutes break? Do let me know. Everything fantastic is going on. Akanksha saying 2 second. Yes, gem halide is the correct answer. Now I hope that everyone is able to understand it. Everyone is able to understand it. Everyone is able to understand. Now, so let's move towards addition of x2. Addition of x2. Try to understand it. Once again, I'm telling you, take care while doing this question. I'm having my dinner. Okay. So you can do it. While studying, you can do your dinner. No problem at all. Now see. CH triple bond CH. Now in front of this, if I say I've added bromine, Br2 excess. In excess bromine I have added. Now what will you answer? So this is being symmetrical. This is being symmetrical. Now one bromine will act as electrophile and one bromine will act as nucleophile. Now you will say, sir, how one bromine? See, this is being symmetrical, no distribution of charge. But due to this pi electron, this is being nucleophilic. This is being nucleophilic. This is being nucleophilic. You know, London forces will get developed. London forces. One will induce the charge on another one. So once the charge has been developed over here, one bromine will act as positive and one bromine will act as negative, and this will attack on the pi electron. Now once it has attacked on the pi electron, what you are going to get? You will get compound like this, CH double bond CH, and bromine will come and form a bond in between this bromonium ion. You will get bromonium ion. You understand? This is being bromonium ion. I must have told you in the first lecture only, bromonium ion. So another bromine will come from the back side. This is anti-addition. Triangle is formed. Yes, three-membered highly unstable ring. Three-membered highly unstable ring is formed. Three-membered highly unstable non-classical carbocation. Non-classical carbocation. Now another bromine will come and attack from opposite side, anti-addition. That will be known as anti-addition, right? That will be negative and anti-addition will take place. Now this bromine will come and attack from this side. What do you got? You got a compound like this, CH double bond CH, one bromine over here and one bromine over here. Now this is being unsaturated. Once again Br plus will come and attack because this is being symmetrical. So anywhere one bromine can attack and another bromine can attack. So compound will be like this because both are being bromine only. So no problem will arise and the compound will be like this. CH, CH, one bromine, another bromine, one bromine, another bromine. So simply you got the answer. Everyone got the answer. Now let me give you one question. Let me give you one question. If the question is like this, CH3, C triple bond C and CH3, and they have given you Br2, Br2 excess. What should be your answer? What should be your answer? Just try in your brain and then I will write down the answer. You have to answer it. Yes, sir, we have got the same answer. You have to find out, yes, you have got the same answer, different answer. Now I'm going to write down the answer. You do let me know that, yes, your answer is like this. So I'm going to write down the answer. According to me, the answer is CH3, CH3, one bromine on this carbon, another bromine is being on this carbon, one bromine on this carbon, another bromine is being on this carbon. Is this your answer? Yes, if you study and if you are giving the answer, definitely Ames tally is not far away. Yes, you can get Ames tally. Drop doesn't mean anything. If you see the channel, number of students they have taken drop and they are right now in Ames tally. Just study with your full brain, full mind. No problem is going to get. Yes, this is the correct answer. This is being the correct answer. Now, addition of dihydrogen. Dihydrogen is what? Dihydrogen means H2. 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 Now, this is very simple. See, already I have told you kids, if you remember, if you are regular to this session, you know very well the answer of this question. See everyone, those who are regular, CH3, C triple bond C, CH3. If I am having this compound and if I make arrow like this, Zupak, one arrow, Zupak, second arrow, Zupak, third arrow. And if I write over here H2 nickel, if I write here H2 PDC and here Na liquid ammonia. So these are the three reactions and let me give the names. This is being A, this is being B and this is being C. If you are regular students, you can easily answer it. Chupak is within second, fraction of second, chupak. If you're going to blink your eyes and you're getting answer. Chupak. Chupak is just blinking your eyes. I got the answer. Chupak. Okay. King Life, you got it? Chupak is when you're going to blink your eyes and you're going to get the answer. Chupak. Now, ding, 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 ding. What's the A? You know this A is being, I'm going to write. Do let me know. I'm going to say this is being Birch reduction. Birch, B-I-R-C-H reduction. Birch reduction. And your answer is going to be transbutene. Transbutene. Agreed or not? Transbutene. Everyone agreed or not? Say yes or no. Everyone say yes or no. Yes or no. Now this is being Lindlar's catalyst. Lindlar's catalyst. What should we answer? Cis alkene. CH3 CH double bond CH CH3 cis alkene. Agreed. And now these are partial reduction. This is being complete reduction. You will get butane. CH3 CH2 CH2 CH3. All three products. Are you agreed? You see, if you have done some hard work in alkene and that hard work is fruitful in case of alkyne, that you are able to understand. You are able to understand over here that everyone is able to understand or not. Is everyone getting benefit or not? Yes. Now see everyone. So are you ready? Are you ready everyone? Now see. I'm going to give you one question. I'm going to give you one question. Try to understand it and try to answer it. Are you ready, everyone? Everyone, are you ready? I'm going to give you one dancing question. See. Everyone see to it. Suppose if I'm provided with CH, triple bond CH, and this has been reacted with NaNH2 excess of NaNH2, soda amide in excess. It has given A. Now this A has been treated with C. This A has been reacted with Br CH2 Br, and it has produced B. Now this B has been treated with H2PD, carbon. It can be given like this, or they can give you like this, or H2PD, barium sulfate, charcoal, boiling xylene, quinoline. So it has given C. So my question is, what is this C? Try to find out what is being C. Everyone. What is being C? Either this is given or that is given. All they are being Lindlar's catalyst only. All of them are being Lindlar's catalyst only. All of both the two type of reagents are being Lindlar's catalyst. Now, it's very tough to draw the structure in the chat section. So I'm going to write down the products and you have to tell me whether you are agreed with this product or not. Okay. So let me say this compound is having two acidic hydrogens. So two acidic hydrogens. So definitely you are going to get Na, C, triple bond C, Na, disodium acetylide. Agreed or not? Disodium acetylide. Agreed or not? Everyone agreed? Agreed. Now see, focus over here, everyone. If this is going to react with this compound, one NaBr will eliminate out from here and one NaBr will get eliminate out from here, right? This is nucleophilic substitution reaction. So this carbon is okay. This carbon will remain like this only, C, triple bond C, and how many carbons will come into this life? 4 more carbons. See, CH2, 3 carbons, and this is being 4th carbon, CH2. Now you can see this is the compound, and when this compound is going to react with Lindlar's catalyst, you will get cis alkene, and cis alkene, this is going to react with Lindlar's catalyst. What you are going to get? Your product will be like this. See to it, everyone. This is your product. And if I do the ozonolysis of it, we can extend this reaction. This reaction will go ahead. So everyone agreed this is cis cyclohexene. The answer is being cis cyclohexene. Cis cyclohexene. Everyone agreed or not? Is your answer, is this one only or not? Kids, show me the thumbs up that if it is your, we have reached to 100 likes. That's really awesome. Fantastic, stupendous performance accomplished with this concept. If your answer is like this, I can see your thumbs up. I can see your thumbs up. Now see my haircut. You can see no divergence, no need to comb it again. So see, very small hairs are there, so that I can totally focus. Now everyone, see to it. Addition of water. This is really very awesome. Addition of water. Now if I simply place alkyne like this, if I place acetylene like this, and in front of this if I put water, now water will not show reaction, no immediate reaction. It will take months and years to react. Water is not going to react easily, will take months or years, will take very long time, will take very long time to react. Now see why it is going to take too much time during reaction. If we are going to react, so see, this is being nucleophilic part. Nucleophilic part means rich in electron, pi electron. So water is like H delta positive and OH delta negative. So H plus will attack over here, and once H plus is being attacking, you will get compound like this, CH and one H, and this is having positive charge, you can see. Now this is really very important thing. If I say that the hybridization of this carbon is sp, this is being sp, and sp hybridization means electronegativity is 3.25, and once it has developed positive charge, then it has become much more electronegative, and positive charge is not stable on more electronegative carbon. Do remember everyone that positive charge is not stable on electronegative carbon. Sagar, let me complete. Now only a little bit is left, so let me complete it. If we are going to take break, it will take too much time. Or if you want break, then do let me know. I can give you 10 minutes break. If everyone says, then I can give you. But I think let us complete it. Everyone, you want break? How many of you want break? Show me the thumbs up that yes. Yes, then I will give you break for 10 minutes. So, positive charge is highly unstable. Positive charge is not stable, or you can say positive charge is highly unstable. On more electronegative atom. So this compound is highly unstable. See, here it is having 8 electron, here it is having 8 electron, and here it is having just 6 electron. This reaction will not come in the forward direction, and this reaction will go in the backward direction. This is very slow step, very slow step. Because intermediate is highly unstable. Okay, I will let you know. Say, everyone saying no break. Take see. That's really fantastic. You got Bangalore Medical College. That's congratulations. That's your hard work, and that's why success was waiting for you, and you got it. That's really awesome. Now see everyone. This is highly unstable. Now, this reaction is not going to take place easily. So whenever reaction is going to take too much time, that means its activation energy is very high. For this reaction, I would like to say activation energy is very high. EA means activation energy. Activation energy, this means activation energy. Activation energy is just like cutoff. cutoff is very high, activation energy is very high, very high. So what should we do? Whenever the activation energy for any reaction is very high, what we are supposed to do? Whenever the activation energy for any reaction is very high, what we are supposed to do? If you add positive catalyst to it, then the activation energy will come down, and we teachers, good teachers, are always the positive catalyst. If kid is preparing without good teacher, he's or she is going to take too much time to cross that entrance examination, that is being the barrier, energy barrier. And if you're getting good teacher or team like us, they are going to decrease the activation energy, right? So catalyst should be added. If catalyst, now see what catalyst we can add and how the reaction will get proceed. Everyone see to it. So for reaction of alkynes along with water, we have to add, we are supposed to add what we are supposed to add, kids? We are supposed to add HgSO4, 1% HgSO4 and 40% H2SO4. So that's why this catalyst is used. This is the role of catalyst. Why this catalyst has been used, why this thing has been used, just to increase the rate of reaction. These things are added to increase rate of reaction, right? Now, whenever the mercury is used, do remember, whenever the mercury is getting used, it will follow Markovnikov's rule. Mercury means Markovnikov's rule. Always keep in your brain. Mercury means mercury means Markovnikov's rule. Right now, though, it's okay because it is being symmetrical alkyne. No problem is there. So one side you can add H and one side you can add OH. Right now there is no problem. This side positive charge you can add OH negative, this side negative part you can add plus charge, and you will get the answer. What answer you are going to get over here? See, everyone see to it. You will get CH2 double bond CHOH. This hydrogen is being acidic. Why this hydrogen is being acidic? Because it is attached to negative. Once this hydrogen is losing it, once this hydrogen is going from the life of it, it will become O negative CH double bond CH2. So this oxygen is saying, hey proton, you go. I don't require you. Once you are going to leave me, I will do resonance. So I don't need you. Proton is saying, I need you right now. But this oxygen is saying, I don't need you at all. I don't require you at all. So this is going to do resonance. And once the resonance is taking place, you will get compound like this and CH2 negative. Now this proton will come over here and it will say to carbon, hey my God, hey my Lord, please, I need you right now. Oh, come on. So the compound will be like this. Now kids, from this to this, and from this to this, it has taken too much time. In your examination, you won't be having this much of time. How many of you want that you can do this question chipak, reflex action within second? Just blink your eyes and you will get the answer. How many of you want? Hey kids, do let me know. Just blink the eyes and you're getting answer in front of you. No need of this much of working. Yes, do let me know how many of you want that magic to happen, to take place by HSP Baba. Yes, everyone, do let me know. Now see, the same question I'm going to show you with another technique. Everyone see to it. See to it. CH triple bond CH, and whatever I did over there, this is also known as tautomerism. From here to there, this was tautomerism only, nothing else. This was the tautomerism. One day I will take lecture on tautomerism, don't worry. Okay, now see, this is your question. Just do what? Markovnikov's addition. 2H delta positive, because there are 2 pi bonds. 2 pi bonds will shift over here. So you will get negative, and you will get positive and positive, double positive, double negative. So you got the answer. See, within fraction of seconds, you got the answer. So your answer is like this. You see to it. Are you able to understand or not? Do let me know. CH and CH, this side oxygen and this side 2 hydrogens. So this is the answer. Any question is there, you can do it within fraction of second. Just remember Markovnikov's rule. Suppose examiner has given this question. This question has been asked twice. C triple bond CH. Now see, Markovnikov's rule says what? Markovnikov's rule says, it states that negative part of the reagent will go to that carbon which is having less number of hydrogen. Do you remember? Which is having less number of hydrogen. Markovnikov's rule says negative part of the reagent will go to which carbon which is having less number of hydrogen. So this is going to be the answer. So what answer you have got? Everyone do let me know what answer you have got here. Here the answer is acetophenone is the answer. This is being acetophenone. So very good. One kid has written the name Vedhajanani. Yes. So let me give you one question for you. Acetophenone. That is really awesome. Acetophenone. Now let me give you one question. Just try it and tell me what's the answer you are going to get. Everyone. CH3. C triple bond CH. This is your propyne is allowed to react with water in presence of 1% HgSO4, or simply it is written like this: Hg 2 plus mercuric and H plus, that is acidic medium. What answer you are going to get? Answer, everyone is going to get the answer, but how much time you are going to take, that is the most important thing. In what time you are going to get the answer? Let me check it out. And how much time? Acetone. Oh my god, everyone is able to do it now. See, it's really awesome that Markovnikov's rule says that negative part of the reagent will go to that carbon which is having less number of hydrogen. So the answer is here, CH3 CO CH3. Now this has increased your speed or not? This has increased your speed or not? Do let me know, everyone. It has increased your speed or not? Yes, your speed got increased. Now this is going to be the last reaction for today's session. This is going to be the last reaction. See, polymerization. Everyone see to it. Polymerization. If I take 3 moles of acetylene, CH triple bond CH, and on reaction with red hot copper tube, iron or copper tube, at 500 to 600 degrees Celsius, 500 degrees Celsius to 600 degrees Celsius. What I will get? I will get benzene. This is given in your NCERT. This is given in your NCERT. Now, In place of it, if I take propine, what should be answer? 3 moles of propine. If I take 3 moles of propine and same reaction, if I am going to do, what answer I will get? This polymerization red hot copper tube. This is today's question. What you will get at 500 to 600 degrees Celsius? What should be the answer? This is homework. You have to write down the answer of this question in the comment section. I'll be waiting for you. So this was all about, oh my God, Pitha Janani has already given the answer. Already the answer is out. Oh my God, so fast, kids, really, you are very fast. This is answer. This is known as macetylene. What is the general name? So remember, IUPSC name examiner will not ask macetylene. This is macetylene. Macetylene is the answer. Macetylene is the correct answer. Macetylene. Benzene, toluene, a 1-methyl, toluene, 2-methyl, xylene, 3-methyl, 1,3,5. Macetylene. So now, ozonolysis of alkyne already have explained in previous lecture, or if you have not attended that lecture, then kindly you can go and see the previous lecture. In the previous lecture, ozonolysis of alkyne already has been completed. Okay, kids, so this is all about today's lecture. You enjoyed it or not? Now let me give you one question, big better question, and I will wait for the answer of that question. See the question. Question is, see everyone, what's the question? Calcium carbide water gives A has been treated with NaNH2 excess gives B has been treated with methyl bromide excess gives C reacted with H2 PD carbon gives D has been treated with HCl gives E reacted with alcoholic KOH alcoholic and heat gives F reacted with bromine water gives G has been treated with NaNH2 excess NaNH2 excess gives H. Now H has been treated with O3 and water to give products. What are these products? That you have to answer it in the comment section. These products you are supposed to find out and answer me in the comment section. Will you be able to do it? This is your homework. For today. and let me take the screenshot of it so that even I can keep it in my brain that what question has been given by me. Let me take the screenshot of it so that I can remember what question has been asked by me. So kids, I will wait for the answer of this question. Okay. Nice question. Or you can take the screenshot of it. Or should I do it right now? Or should we deal with such type of questions? How many of you are having energy to deal with such type of questions? These are known as really mind maps, brainstorming questions. So, will you be able to do this question? Yes, everyone. Okay. So, you can try. You can try. So, all the best. This session is completed of alkynes. Find A is question. Oh my God. A, so definitely you can find out. Okay. So, right now you want to try, or should I give it for homework? Should I give it for homework, or right now you're going to try? Just do let me know in the chat section. Right now you are going to try for it. How many of you saying, sir, right now we want to try it? Say in the chat section, how many of you are saying, right now you want to try? Say thumbs up, show me the thumbs up and write down yes right now. Yes right now. If you want to try, yes right now. Okay, Sagar is saying homework. Homework. Okay, everyone is saying homework, right? Okay. So it's homework. It's homework, right? Homework. Okay. Prashant Kumari maths. Madha, not maths. Try. Both okay. Okay, both okay. So do one thing. What should I say? I'm unable to understand. Some are saying right now you want to try. Some are saying homework. Everyone come to the one point. Just come to one point. So everyone is going to try it right now. Yes, try it out. So I will give one more homework question. Yeah, okay, I got it. So we will do it right now. So see, everyone see to it. So help me, what is A? So help me, what is A? What is A? Everyone help me, what is A? If you want to do it right now, say what is A. Everyone write out in the chat section what is A. If you want to do this question right now, just to let me know what is A. Ethyne, very good. So this is being acetylene, very good. Acetylene. One, so we have got acetylene. What is B? Disodium acetylide, Na. C triple bond C Na, disodium acetylide. So this reaction will take place and both sides will get methyl. This also we have got CH3 C triple bond C CH3. Everyone agreed? Everyone agreed we will get this? Everyone agreed? Now this is Lindlar's catalyst. Lindlar's catalyst. We will get cis butene. Everyone agreed that we will get cis butene. Agreed till now? Agreed everyone? Butene, cis butene. That is when butane. This was butane. This one was butane. And this we have got cis butene. Now, if you are reacting with HCl, either way you can react. So you will get CH3, CH, now CH2, CH, Cl, CH3. This is known as electrophilic addition reaction, EAR, electrophilic addition reaction. Now, this alcoholic QH elimination E2 reaction elimination already I have taught to you. Now, what you are going to get? You will get, so this is being alpha carbon, beta carbon, beta carbon. Oh my God, Sedgwick product and Hoffman product. So Hoffman or Sedgwick, which is going to be major? Sedgwick product will be major. Sedgwick, this already I taught you. Sedgwick will be major, right? Either we can say Sedgwick or we can say Jetsef. Both mean same. Sedgwick, or it can be written like this, Sedgwick. They can write it like this, Sedgwick. Now, double bond, bromine water will get decolorized. So, once the bromine water is getting decolorized, we will get CH3, CH, Br, CH, Br, CH3 and bromine's color will get decolorized. Till now, are you happy? This is your answer. Now, see, NaOH2, one HBr will go from here. It will give vinyl bromide and another HBr will go from here. Now triple bond will get originated. Triple bond, so we'll get CH3, C triple bond C, CH3, and this is oxidative ozonolysis. In the previous lecture, I have told you. Gopika, sir, Gopika Sri from Ains, New Delhi. Oh my God, Gopika. A pleasant surprise. I'm really happy. Oh my God. From where you got my address? Wow, that's really awesome. Really, see kids. Gopika Sri. Gopika Sri, right now you are present. Yes, that's really awesome. Really awesome. Now see, oxidative ozonolysis. Oxidative ozonolysis. So oxidative ozonolysis, what you are going to get? So how it is going to take place? First CH3, C double bond O, C double bond O, CH3, and the bond will break from here and you will get acetic acid. So the answer is 2 moles of acetic acid. 2 moles of acetic acid. This is your answer. This is your answer. 2 moles of acetic acid. Everyone, is this your answer? Is this your answer? Do let me know. Wow, that's really fantastic. Now, I have to give you another question because this question we have done right now. This question we have done right now. So, should I give you another question? Should I give you another question? Everyone agreed? Agreed, everyone? Do let me know that yes, sir, we are agreed. Now, see, everyone. If I say I'm provided with calcium carbonate, CaCO3. So calcium carbonate was allowed to strongly heated it has given A. Now A and minus carbon dioxide we have got A. Now A has been treated with carbon, it has given B. Minus carbon monoxide. Now B was treated with water. It has given C, and C has been treated with excess of sodium to give D, and D has been treated with, so let us suppose not excess, just take one equivalent of sodium D, and this was treated with methyl bromide to give E. E was treated with sodium liquid ammonia to give F, and F was treated with HBr peroxide, HBr plus R2O2 peroxide to give G. G was treated with alcoholic KOH and heat, KOH alcoholic and heat to give H, and H was treated with HBr to give I, and I has been treated with KOH alcoholic heat to give J, and J has been treated with O3 zinc and water to give K plus L. So what is K plus L? This is your homework. K plus L, this is your homework. So I have to take screenshot of it. This is your homework. Okay, this is your homework. So bye to all of you kids. We'll meet you very soon in next session. Okay, all the best. We'll meet you in the next session. Bye to all of you. All the best. Bye kids. A is CAO. Yes. 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 Bye. Bye. Bye kids. Bye.